Hello everyone, I'm Sweet Valberry, a YouTube content creator focusing on topics related to AIGC. I started researching AI-generated art at the beginning of 2023 and have witnessed the rapid advancement of AI technologies over the past 2 years. Nowadays, with just a few lines of text instructions, you can generate images, videos, or audio at a professional level. In my view, this is not just a technological breakthrough, it's a redefinition of the very nature of creation, allowing anyone to easily realize their creative ideas. However, I've noticed that while many people are interested in AI, they hesitate because they don't know how to get started. That's why I'm excited to team up with Olares to jointly launch this comprehensive ComfyUI course. The course content is wide-ranging, from interface operations to plugin installation, from core principles to commercial applications, all explained systematically. We've also deliberately designed a tiered learning path. Whether you're a curious newcomer or an experienced professional seeking breakthroughs, I believe you'll find something valuable here. For beginners, the most common roadblock is the complexity of installation and environment configuration. Getting an AI model up and running requires patience and experience. GPU drivers, CUDA versions, various dependency libraries, all need to be installed and selected carefully. One wrong move and you may run into a pitfall, costing lots of time and effort. Olares solves all these preparation headaches. Olares is an open-source personal cloud operating system designed to empower you to own and manage your digital assets locally. It leverages Kubernetes to efficiently manage host resources and comes with a built-in app marketplace supporting one-click installation of various AI applications. You can even easily share models across different applications, dramatically lowering the barrier to entry. And most importantly, installation is completely free. You can check the video description for instructions on installing Olares and easily set up your own local AI system. Before diving into the hands-on part, let's spend some time on the basics. Think of it as sharpening your axe before chopping wood. Preparation pays off. You don't need to understand every technical detail under the hood of AI art, but a high-level overview will make everything else much easier to learn. First, we need to understand Stable Diffusion, which is a foundational model for AIGC applications. Released and open-sourced by Stability AI in August 2022, it can generate high-quality images, realistic, anime, or landscape, using consumer-grade GPUs. Strictly speaking, it's more about image generation than drawing. It doesn't go through the traditional sketching, inking, and coloring process. Instead, starting from an image filled with random noise, it uses a stepwise reverse diffusion process learned during training to gradually denuise and restore image content, ultimately producing finely detailed, high-quality images. Models capable of this gradual denuising and image restoration are known as base models. Through different training materials and methods, models can learn unique denuising techniques, leading to a diverse array of generative models. Besides the Stable Diffusion series, there's the popular Flux series, China's native Q1 image series supporting Chinese input, Lumina Image 2, which can accept system instructions, and video generation models like Wan and Hunyuan Video. The open-source community frequently fine-tunes these official models for specific purposes and shares the results. For example, based on Flux there's Magic Mix Realistic, Ghibli Style, and Mysterious. Using these specialized models, you can more easily generate finished works in your target style or type. However, these fine-tuned models are still base models and tend to be quite large. There's a more convenient type of model for producing specific characters or styles, LoRa models. These are small, flexible to switch, but deliver equally excellent results. For example, a 36.6 MB Ghibli-style LoRa, when used with a Flux-based model, can easily match the results of the much larger 11.08 GB fine-tuned Ghibli-style model. When generating images, if you simply let the model act freely, it's unlikely to meet your objectives. You need to input prompts to tell the model what you want. However, the model doesn't understand human language, so we need a text encoder. Its job is to translate prompts into conditions that the model can understand. In most cases, we use CLIP as the text encoder. Sometimes we introduce NLP models like T5XXL to provide enhanced language processing and text embedding capabilities. When using different models, you need to select a paired text encoder. Some models even require multiple encoders simultaneously. For example, the Flux.1 dev model needs both CLIP-L and T5XXL together. Some models, like Lumina Image 2.0, directly use Gemma-22b, which is a large language model, as the text encoder. This enables not only native understanding of Chinese, but also the ability to accept system instructions, drawing from the perspective of an artist, photographer, or child. The image encoder is another type of translator, parsing image content and translating its visual information into semantic embeddings for the model to use. For example, when IP adapter inputs a reference image, it uses clip-VITH or clip-V-big-G. When generating images, the model doesn't work directly in the visible pixel space, but operates in a low-dimensional latent space, creating latent vectors. These latent vectors are the language of the model, the way it expresses images, though not directly interpretable by us. Just as the model uses encoders to understand text and image inputs, we rely on a variational autoencoder, which enables bidirectional conversion between latent vectors and visual images. Similar to text and image encoders, different models usually specify their own recommended variational autoencoders as companion components. In specific tutorials, I'll introduce some commonly used combinations. The base models such as Stable Diffusion, Flux, and so on are just model files, in essence, collections of numbers. We need tools to actually use them. Early on, users could only generate images by running code, very inconvenient, but in August 2022, the same month Stable Diffusion was released. Automatic 111 created and published Stable Diffusion Web UI, named SD Web UI in short, based on Greyjoe. With this, we can interact with models via a browser interface, using fill-in-the-blanks, selection boxes, sliders, etc. to adjust parameters, making it easy for non-programmers to enjoy AIGC. The UI is simple, intuitive, with clearly organized function modules, ideal for beginners. In January 2023, ComfyUI open-sourced ComfyUI. This tool centers on modular, node-based architecture, emphasizing highly flexible workflow design. By creating and connecting nodes, you can not only achieve all the functions of traditional web UI, but also access underlying logic, fully understand and control every step of the generation process, perfect for developers and technical enthusiasts wanting a deeper understanding or optimization of model mechanisms. In January 2024, Zhang Lel Lumen built Stable Diffusion Web UI Forge based on SD Web UI. It inherits the clean UI, requires less VRAM, and delivers better performance. However, the ecosystem is smaller, and some plugins lack compatibility, so it suits users who prioritize a simple interface but want performance and memory optimization. Around these open-source models and platforms, the community has also developed a series of tools and technologies such as ControlNet, IP Adapter, LoRa, and plugins offering various functionalities. Together, they form the Stable Diffusion ecosystem that we will be exploring in this course. Although these platforms have significantly lowered the barriers to using models like Stable Diffusion, their installation and deployment processes remain quite complex. Many users, for the sake of convenience, opt for online image generation services such as Midjourney, or rely on large language models like GPT and Gemini to generate images. These options are indeed convenient and generally provide a good user experience, but they also come with three major drawbacks. 1. Limited free usage. Long-term use can be expensive. 2. Privacy risks. Your creative process, source materials, or ideas may be recorded. 3. Restricted functionality, especially when it comes to fine-tuning parameters or handling special scenarios. Flexibility is lacking. By deploying your own AIGC environment on the Olares, you can not only enjoy the convenience of online services, ready to use anytime, anywhere, but also reap the twin benefits of local deployment: free usage and enhanced privacy. This gives you peace of mind and lets you enjoy the creative process to the fullest. In this tutorial series, I will guide you in using the open-source platform ComfyUI, both locally and on the Olares system, in combination with open-source models such as Stable Diffusion, Flux, Qwen, and Wan. To smoothly run ComfyUI for image or video generation, as well as other AIGC applications on Olares or your local environment, it is best to meet the following hardware requirements. at least 12 GB of GPU via RAM, 16 GB of system RAM, an 8-core CPU, and at least 200 GB SSD storage. Regarding the GPU, you must use an NVIDIA card, as many AIGC frameworks and dependencies require CUDA support. Using a non-NVIDIA GPU will result in various errors that can be quite frustrating. Specifically, GPU VRAM is the most critical parameter. It determines the maximum image size and the longest video frame count you can generate. Based on my experience, if your VRAM is less than 12 GB, running video generation models is highly likely to cause out-of-memory OM crashes. Given the same VRAM amount, the more advanced the GPU, the faster the rendering will be, so choose based on your budget. RAM is equally important. I recommend at least 16 GB. It's much cheaper than VRAM, so if possible, you can upgrade to 64 GB. Do not skimp on storage. Model files are getting increasingly large. For example, the FluxDev model is 22.1 GB, and the OneFun model is as large as 32.8 GB. The storage must be SSD, otherwise, loading a model might take several minutes, greatly affecting usability. Regarding the CPU, while there are no strict requirements in theory, more cores are always better. The CPU is often tasked with data preprocessing, so better concurrency is beneficial. That concludes this lesson. Today, we outlined the overall course framework, learned about AIGC background knowledge, reviewed the characteristics of mainstream platforms, and discussed hardware configuration recommendations. In the next lesson, we will move on to hands-on practice, guiding you step by step through installing ComfyUI and generating your first image. See you in the next session.